Here in Algebra 1, New York State Regents curriculum, the first topic we're going to cover is polynomials and exponents. So the first thing we're looking at within this unit is adding and subtracting polynomials. What we need to know is what exactly is a polynomial. First off, it's basically the sum of monomials. So the sum means we are adding, and we are adding a whole bunch of monomials. And now we go through what a monomial, binomial, and trinomial are. So if we think about our prefixes, kind of like a bicycle and a tricycle, they have the same thing. They have the same prefix as we do here. So a bicycle has two wheels. So a binomial here is going to have two unlike terms. And a trinomial, like a tricycle, has three unlike terms. And a monomial is mono stands for one. So we have one term, two unlike terms for a binomial, three unlike terms for a trinomial. Now, what exactly is a monomial? A monomial is a number or a variable that we use in algebra. So it could be anything from the number 7, the number 23, the variable x, the variable y. It could be any variable with an exponent as well. X squared, x cubed. It's all the same thing. It's one term. Now, a binomial, we are adding two unlike terms. So we can take our previous monomials and add or subtract. So we could have 7 plus x, or we could have 23 minus x squared. So those are examples of binomials. Notice the number 7, the number x, two terms, binomial. And last, our trinomial, we have three unlike terms. This is where we start really getting into exponents. They typically look like x squared plus x plus 3. So yes, we have the variable x in there twice, but the one is being squared. So the first term, x squared. The second term is x. The third term is 3. They are not alike. So trinomial there. When we have polynomials, trinomials, binomials, we have what's known as simple standard form. This is when the polynomial contains no like terms and they are put in order from the highest exponent to the lowest. So if I take a look at our example here, 5x cubed plus 8x squared plus 2x cubed plus 7, I want to look for the highest exponent. And the exponent is always going to be on the variable, and we look for the highest exponent. So here we have an exponent of 3, an exponent of 2, an exponent of 3, and there's no variable x, so there's no exponent to deal with there. The highest number we have is x cubed, so I want to combine what we have here. We got the 5x cubed and the 2x cubed. I can add them together, and we get 7x cubed. So I took care of those two guys. And I now look what's next highest. So here we have x squared, no exponent, so the 8x squared comes next. So I took care of that. And then last but not least, the last thing we have is plus 7. So there we have simple standard form, highest exponent to lowest. Exponent of 3, exponent of 2, no exponent there. Definition-wise, we got a few words here that we got to figure out what they mean. We got coefficient, degree of a polynomial, the constant term, and the leading coefficient. So what does this look like? Well, a coefficient is nothing more than the number attached to the variable. So if I take a look at our previous example here, the 7x cubed plus 8x cubed, coefficient, I actually got a couple coefficients because I have 7 on the x cubed, and we have an 8 on the x squared. So those are the coefficients of the previous example. Now the degree of a polynomial is the highest exponent, the exponent on the leading term. So here we have an exponent of 3. And that's usually on the leading So the highest exponent in this, again, we'll use the same example. The highest exponent is 3. So that is the degree of our polynomial here. The constant term is pretty much what it says. It's constant. It's never going to change. And it's usually the standalone number. So if I use the same example up here, the one that we did, what can never change? Here we have 7x cubed. That can change depending on the value of x. Same with the 8x squared. That can change depending on the value of x. 7's always going to be 7. I cannot change the number 7 to be anything else. So that is the constant term in our example. And then the leading coefficient, we already said a coefficient is the number attached to a variable. So the leading coefficient is going to be the number attached to the first term. So first term up here is 7x cubed. So the coefficient on that, again, is also 7. So those are the few vocabulary words that we need to deal with, especially with these examples. And on this box, we have 6 different examples. I'm not going to do all of them. I'm just going to do a few of them. And we'll go through, put them in simple standard form, state the degree, what kind of polynomial, and what is the leading coefficient. So 3x squared, we'll do this first one here, 3x squared plus x to the 5th plus x minus 7x. So I go through, I find the highest exponent here, so exponent of 2, exponent of 5. I don't see an exponent on the x or the 7x. So a little tidbit here, if I see the variable and no exponent, automatically I can say it has an exponent of 1. So exponent of 2, exponent of 5, exponents of 1. First one we want is the highest one. So here we have x to the 5th, and we're always going to bring the sign that's with it. So it's a positive x to the 5th, so I put x to the 5th. If it's starting off, I don't have to put the sign. So I don't have to put the plus x to the 5th. Next up, I want to do the next highest, so I compare 2 to 1 and 3x squared. No sign out front of the 3, so that means we can presume it's a positive 3x squared. It takes care of that guy. And then x to the 1st minus 7x to the 1st. Because they are the same variable, same exponent, I can add and subtract these guys accordingly. So x minus 7x, well, I need to know what number is in front of the x because I can only add or subtract the coefficients. If I see the variable with no number out front, I can automatically presume that is 1 as well. So if I don't see an exponent, the exponent is 1. If I don't see a number out front of a variable, I can put a 1 in front of that variable as well. So I have a positive 1 minus 7, and that ends up being minus 6x. So I'm going to state the degree, the highest exponent, so 5, 2, or 1. Highest exponent is 5. The type of polynomial, I just count the number of terms I have. So I have 1, 2, 3 different terms. So that means it's a trinomial. Leading coefficient, I want the number that starts off my example here. So I have x to the 5th. Just like before, I don't see a number out front. So I can presume it's the number 1. So that's going to be my leading coefficient, the number 1. I'm now going to look at the third example here, the 2x plus 3x minus 9x to the 4th. Simple standard form, again, order from highest exponent to lowest. Here I have x and x, so exponent of 1, exponent of 1, and then the last guy has an exponent of 4. So the highest exponent is 4. So I bring the whole thing to start off with. So the minus 9x to the 4th. And then I have 2x plus 3x. Because they're the same thing, I can just add the numbers. 2 plus 3 gives me plus 5x. State the degree, the highest exponent. Here we have 4 is our highest exponent. The type of polynomial, I just count the number of terms. I got 2 terms, so that means we have a binomial. And then the leading coefficient, what number am I starting my problem off with here? -9. And now we're going to do the last one, the 8d to the 6th minus 5d plus 4e to the 10th plus 3 minus 12g. So to put this in order, first things first, I did say we got to put the highest exponent as first as well. So I go through 6, 1, 10, no variable. So there's no exponent to deal with, and then g to the first. So the question becomes, how do I put this in order? I got letter D, I got the letter E, I got the letter G. How exactly am I supposed to put this in order if I don't have all the same variables? Pretty much we go alphabetically. So if I'm dealing with multiple variables in the same problem, I'm going to start off with the variable that comes first in the alphabet. So D, E, and G. Which letter comes first? The letter D is going to be first. So I look at exponent of D's. So I got 6 and 1. 6 is highest. So we are going to say 8d to the 6th comes first. And then minus 5d. Next up, the next variable that we have is E or G. E comes first, so that's what I'm going to put. So there's no other e's except the positive 4e to the 10th. Then I got the number 3 and the minus 12g to the first. Again, variables always come before solid numbers, so minus 12g. And then last but not least, plus 3. And then the degree, again, the degree is the highest exponent. In this case, it is 10 because 10 is the highest exponent within the problem. So we can say that that's the degree. Normally, it goes on the leading term. We could say it's 8d to the 6th, but again, we want the highest exponent within the problem. Type of polynomial, we got 1, 2, 3, 4, 5 different terms. So once we get beyond 3, everything is polynomial. Then the leading coefficient, what number do we have out front? To start off with, it's the number 8. So that is putting simple standard form and combining some like terms within a expression. Here we have some operations to do. So we're going to be adding and subtracting polynomials here. So first things first, we got 4x squared plus 6x plus 7 plus 2x squared plus 3x plus 1. Notice these are in parentheses. So parentheses means it's this guy, everything within that set of parentheses plus the other guy. The only way we can do this is by combining the like terms. So I have to be the same variable with the same exponent in order to add and subtract. So how do we do this? Adding is pretty easy. We just look at what's the same. So we have 4x squared. And then we have a 2x squared in the other one. So 4x squared plus 2x squared, 4 plus 2 gives me 6x squareds. So I took care of the x squareds. And now I have an x plus 3x. So we have 1x plus a 3x. So 1 plus positive 3 gives me a positive 4x. And then 7 plus 1 gives me plus 8. So again, notice I'm adding the same things. I'm adding the x squareds. 4 plus 2 gives me 6. I'm adding the x's. 1 plus 3 will give me 4. Then I'm adding the solid numbers. 7 plus 1 gives me a positive 8. So we can do it horizontally like that. Problems like number 2 here, it's easier to set them up so it's vertically rather than horizontally. And I'll do it both ways here. I'll do the horizontal way and the vertical way, and you can pick which way you so desire. Horizontally, we're going to do the same thing that we did over here, but we have to be careful. We are subtracting here. So whenever we subtract, we have to be aware of the signs, and we have to be aware of the numbers that we're working with. So it's not 3x minus x cubed, and then I look at everything else and go vertically. I am subtracting everything. So first guy is the 3x cubed, and I want to make sure I have an x cubed in the other set of parentheses. So there's 1 right there. So I'm going to be doing the subtraction. 3 minus 1 is going to give me 2x cubed. Now what I want to see, I want to find the x squared. So here I have a negative x squared, and I am subtracting 5x squared. Now this is not negative x squared plus 5x squared. It is negative x squared minus a positive 5x squared. Now when I subtract a positive, I'm going to end up subtracting it. Negative x squared minus 5x squared. I'm going to end up with minus 6x squared. Now a positive 8. I got a number over here, but remember, we got to go in order, highest exponent to lowest. So exponent of 3, exponent of 2. There's not an x in this parenthesis, but there is an x in this parenthesis. So here we don't have any x's, but we are subtracting a 4x. So we are subtracting 4x. And then I can do 8 minus a negative 7. Now when I subtract a negative, I really end up adding. 8 minus negative 7 means 8 plus 7, so I end up with a positive 15. So that is the horizontal way. The vertical way would be lining everything up. So we start off with 3x cubed minus x squared. And what I'm going to do is I'm going to insert a 0x. Now 0 times x, anything times 0 is going to be 0. It's a property we're going to get into later on in one of our units. But because I'm adding nothing, I'm not changing the value of our number here. And we still have plus 8. Now we are subtracting this other number here, whatever it happens to be. So we are subtracting x cubed plus 5x squared plus 4x minus 7. So remember, we are subtracting everything. So we have to do 3x cubed minus our x cubed. So 3 minus 1 gives me 2x cubed. Here we have a negative x squared minus the 5x squared. So negative 1 minus 5 is going to give me minus 6x squared. 0x minus a 4x is going to give me a negative 4x. And then 8 minus negative 7. Again, whenever I subtract a negative, I end up adding. 8 plus 7 gives me 15. So there's the two different ways that we could do it. We could either do it horizontally by subtracting these things, or we can line them up vertically, whichever you so desire. This third problem says find the difference between 10y and 3y plus 6. So find the difference means we have to subtract here. So we subtract the first minus the second. So we really have 10y minus 3y plus 6. So that's the setup versus horizontally. Vertically, it would be 10y minus 3y plus 6. So again, I'm lining up the variables accordingly. So 10y and 3y are vertical. There's nothing up top. So if I want to put a number up there, anytime I want to insert something, I can always just add a 0, and it's going to keep things the same. So 10y minus 3y gives me 7y, and 0 minus 6 gives me minus 6. So there's the difference, 7y minus 6. Number 4, we're going to be doing the same thing. Negative 5m plus 6n plus 8p minus, in parentheses, 6n plus 3m. And again, we can only combine the items that are the same. So I can only add and subtract m's. I can only add and subtract n's. I can only add and subtract p's. I can't do negative 5 plus 6 plus 8 minus 6 plus 3. It doesn't work. You can only do the operations with m's, n's, and p's together. So first we have a negative 5m. We are subtracting, and here's the other m, 3m. So negative 5m minus the 3m means negative 5 minus 3, so minus 8m. So I took care of the m's. Then I have 6n minus 6n. Well, 6 minus 6 is nothing, so they cancel out. There's nothing going on. And then all I have left is the positive 8p. And then number 5, I'll stop here because everything is subtraction and it's getting kind of redundant. But we have 2x plus 4x squared minus 7 minus x squared plus 7 minus 8x. Sometimes they like to rearrange things and jumble them around. So what I would do is I would just rearrange it so it's in simple standard form. So the first set of parentheses, I want to rearrange it so it's all in order. So 4x squared will come first, because it's got the higher exponent. Then we got the positive 2x. Again, we're starting off, there's no sign out front, so it's automatically a positive. And then minus 7. And we are subtracting. And I'll just put a set of parentheses so that way I'm aware that I'm subtracting the whole thing. And I'm going to do the same thing. I'm going to rearrange it so it's everything is in order. So we have an x squared minus 8x plus 7. So top to bottom, I'm going to be subtracting. So 4x squared minus x squared. 4 minus 1 gives me 3x squared. 2x minus negative 8x. So again, anytime I subtract a negative, I'm going to end up adding. So 2 plus 8 gives me a positive 10x. And then negative 7 minus 7. So that ends up being minus 14. So 3x squared plus 10x minus 14, there is the difference. 6, 7, it's all subtraction, so it's the same thing. So again, combining like terms, rearranging things so they're in simple standard form is going to make life much easier. Adding, we don't have to worry too much. We just follow the signs of whatever's inside parentheses. Subtraction, we have to be aware that we are subtracting everything. So it's the top minus the bottom number. So that's why 2x minus negative 8x, we use the calculator if you need to, gives you a positive 10x. It's not 2x minus 8x, it's 2x minus negative 8x. And that is writing things in simple standard form.